From sphere mountings Part 1, gyroscopic or inertia-reacted guidance systems are felt to be the best ways for tracking in actual use. In the case for the sphere mount, it was noted that functions of a mounting, support and guidance or tracking, may be split and solved separately. In the figure left, the sphere telescope is balanced and stable, buoyed by the displaced fluid below from an annular no-friction bearing, and isolation damped by the thin film of fluid. Any kind of tangential force to induce or initiate an angular motion is limited or stopped only by opposite forces or resistances. One such torque-inducing device, shown in the inertial drive figure, is a gyro or inertial reaction system, which has already been proven. Another, shown next, is by traction for compliant tires, working in pairs with differentials and hydraulic transmissions. A set of lower polar axis contact point may be engaged to prohibit slippage, but will allow differential rotation. Two other pairs at the sphere's equatorial plane may be driven in right ascension, RA, at a proper rate for tracking. Elevation control may be achieved by driving the polar axis set, and the equatorial sets likewise would be driven like a car turning a corner. A 30-meter telescope and surrounding cage structure is superimposed here to identify a basic resolution. The depth of the fluid shown is approximate, and the systems must be selected and sized for balance, holding the CG centric to the sphere. An annular air bearing is positioned to isolate a dry sphere zone for traction if that's going to be desired. In any case, it also serves to isolate a no-freeze zone for water if that is used. Similarly to the TMT, instrumentation is dispersed around the optical array. Working from the baseline, other variations have been investigated that offer improvements. A simple plan view offset shift allows favoring sides for increasing usable space, or for the purpose of reducing the sphere diameters. An extreme case may even be made for an optical off-axis alignment, such as a system shown on the right, which could eliminate the structural cage supporting the secondary optics, resorting to a secondary axis tower as shown. Such an architecture coupled with an entirely open day deck could facilitate an overhead gantry to roam over the mirror array for daytime service and maintenance. Critical would be a more difficult optical system with higher spherics. This, however, may be within the multi-mirror array and the adaptive optics ability to correct. Observe first the surface contour variations of these offset optics designs. Richard Cretan is the astronomy's design of choice, and these offset designs fall into some form of Cassegrainian or Gregorian variations. The Gregorian offers physical dimensional advantages for clearances and secondary tower structures. There may be other oblique axis combinations, but an optimized optical resolution will be necessary before serious architectures can be considered. This schematic shows both the primary focus positions of a Gregorian optical system, as well as centers of curvature for collimation verification, similar to studies previously submitted to the TMT team. The key feature in this schematic is that as this is an off-axis system, the bead screen image lower left can offer a clean presentation of the converging wavefronts, doing this by selecting a proper slant angle intercept a uniform distance d ahead of their centers of curvature. A Hartmann-like target screen for collimation can also be incorporated within the Hightower station at B'. Elimination of the surrounding cage structure for secondary optics support enables having a day deck without obstructions for a free-roaming overhead gantry for mirror services. It is suggested that for thermostability, composite structures may be ideal for the secondary optics tower, and further, that competitive bids may be possible to make it from existing Boeing 787 tooling or even salvaged test hardware. The composite structure from such an aircraft fuselage could make an excellent modular foundation structure for telescope support systems. This would apply to incorporating instrumentation and subsystems to cargo container module standards, or the entire composite tower hotel may be configured for dedicated functional telescope systems, including the gyros. A large open sphere expands the effective day deck and observing floor, providing hoists for instrumentation and heavy subsystems. The day deck is free of columns, enabling complete overhead gantry array service. These views show the lightweight, thermally stable composite structures in black. The green baffle, marked B, is a structure which may be aluminum extrusions or such, but primarily they provide a ballast mass for balance while being able to cool down quickly for thermal stability. These views show the various positions of the sphere assembly in different modes. The day deck angle would be selected for best servicing the mirror array. This is a subtle variation intending to show a secondary tower kick-out angle resulting from a yet-to-be-determined optical design. The design will actually establish the architecture. That's why it's just tentative. The intent of this figure is to show a collimation option and a camera monitor position in support of slide 8 for collimation. Noteworthy for consideration is an in-place vertical cleaning position of mirror segments, window washer fashion. Yet to be determined power platform would be required. There may also be limiting angles to which the segments can be tilted, but it may be easier to clean and service the mirrors if treating them like a building rather than horizontal and trying to get into reach problems. In this study, a curved service ramp following the array curvature is guided on dual track levels to follow its profile. Service doors in the floor and an overhead rail to move mirror segments to the day deck for pickup may support maintenance. As a closed tunnel, it could serve as a clean room, confining aerosols and cleaning byproducts from contaminating the array. The instrumentation also ends up on the day deck in this configuration.